channel got a fun piece of technology today. A LabRadar Doppler Radar Chronograph. What is a Doppler radar? We're going to science for a minute, so we're going to need to put our safety goggles on. A Doppler radar is a specialized radar that uses the Doppler effect to produce velocity data about an object at a distance. What is the Doppler effect?
It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
So how does the Doppler radar chronograph do that? It bounces a microwave signal off a desired target and analyzes how the object's motion has altered the frequency of the returned signal, aka magic. Serious part of the video is over. Before we begin the discussion, how about a little range time? $12.92. Look at that. That's a big jump. Okay. Now let's crunch the numbers. One of the immediate appeals of something like this LabRadar Doppler chronograph is, besides getting velocity at the unit, which you could consider muzzle velocity, you can configure 5 different variable distances and get velocity at those distances. So think of it as setting up 6 chronographs instead of 1. And you can see that on every shot that you take. Now for your current series and for each shot you take in that series, you can also go in and see the energy that round would have at various distances. So for example, at the muzzle for this shot we had 483 foot-pounds of energy. It'll also tell you the power factor. For that shot we had a power factor of 148.1, and our average power factor, which would be for all shots in this series, we have an average power factor of 148.7. If you go down into the display one level lower for each shot, you can see the energy at the various distances that you have desired to see a velocity at. So at the muzzle we have 483 foot-pounds of energy. 30 feet from the muzzle we have 450 foot-pounds of energy. 66 feet from the muzzle 411 foot-pounds of energy, etc. Another very useful piece of information you can see on the display of the unit is some averages for your series. For the shots we just fired through the Scorpion pistol, our average velocity using the Remington green and gold box 115 full grain full metal jacket was 1,298 feet per second. Our highest velocity was 1,319 feet per second. Our lowest velocity was 1,279 feet per second. The difference between the highest and the lowest round was 41 feet per second. Our standard of deviation was 15.3, and we fired 5 shots. Before we continue on, let's review a couple key points from the manual, because you should always read the manual, contrary to what you actually think. Conveniently, I've marked these pages so that way we can get to what we want to see quickly. So specifications. Now there's a lot of things listed that a lot of smarter people than I are going to care about. But the points to me that stand out are velocity range, 65 to 3,900 feet per second. All right, well, that sounds like a good enough range for me. I'm probably not going to go much above 3,900. Minimum time between shots. I should have paid attention to this before. Right now, but 2 seconds. Note to self, no rapid fire. Accuracy of the unit, I'm guessing they mean, not me, because I'm nowhere near this accurate. Plus or minus 0.1%. And then they put plus or minus 1 millimeter per second at 1,000 meters per second. So you could say 3 feet at 3,000 feet per second. Operating temperature. This is again relevant to me.
We're going to skip the Celsius part because we're not in a Celsius caring country. 14 degrees Fahrenheit to 104 degrees Fahrenheit. I can work with that. We will be out plenty of the time where it's below 14, but batteries suck when it's near that cold, so we probably aren't going to take our advanced tech out in that cold anyway, unless it's like a thermal optic or something. Environmental conditions. Indoor, outdoor. I don't know if that means it's waterproof. I don't want to find out the hard way, so we're going to assume it's not waterproof. Okay, so the thing I noticed that is conveniently missing in the specifications is range. Because one of the things I got this, and they're not cheap, is we're going to be doing long-range shooting. We do long-range shooting. You don't see it much on the channel because we often do it when it's cold, and as I said, batteries suck in the cold. So, yeah, whatever. We mostly just do that off camera. But when we do long-range shooting, what I was hoping we would be able to do is to get velocities and energy at 100, 200, 300 yards, say, for 6.5 Creedmoor, for example. So, it's not in the specifications. That's on 7. I checked all the pages in between. 21 is where we eventually, 2021 is where we get to it. And this is where it gets very interesting. I know, Bud Dropper, I agree. It is a known fact that range performance can vary even for the same bullet caliber depending on the manufacturer of the bullet, the model of the bullet, the firearm used to fire the bullet, the tail shape of the bullet, etc. Infinition, I guess that's who owns this company, and its subsidiaries, which must be this company, cannot explicitly guarantee a range performance and thus will not be responsible for range performances differences between shots. Ugh, that was like the wordiest lawyer paragraph ever. Estimated maximum range on standard power. What's standard power? Select the LabRadar transmitting power, standard or low. While standard power offers a longer range measurement range, the low power mode can be useful and perform better on shorter or indoor range and on ranges where objects create signal reflections. Due to foreign government restrictions, the European Union model is restricted to low power setting. So if you are in the European Union, you don't even get to take advantage of this section apparently. So estimated range, maximum range on standard power, 223, 556, 40 to 60 yards, 308, 762 millimeter, 80 to 100 yards, 355, 9 millimeter, 100 to 130 yards. So I guess you're supposed to estimate based on that very narrow selection of calibers where your maximum range is going to sit. And it sounds like it's probably 130 yards. Due to microwave signal nature, range performance of the LabRadar can differ depending on temperature, humidity, particles in the air, signal reflection on the ground, trees, wall, or any surface in the line of fire, frequency channel, electrical interference, etc. I wonder what etc. is. In addition, the projectile's characteristics will also affect performance, such as diameter, tail design, shape, position while traveling in the air. Subparticulates, like sabbats or wads, I'm glad they specified because I was wondering if they meant bees or something, etc. They must mean bees or something. Now that we have a better idea on the characteristics and limitations of the LabRadar Doppler Chronograph, how about a little more range time? Alright, now the Norma out of the Beretta. Again, top right target. Here we go. Okay, we're getting numbers. Okay, got all 5.
We have a review coming specifically for this Norma ammo, but we're including it in this video because, well, it was one of the ammos that we had available when we were, using this LabRadar. Now we're going to keep most of our comments specific to the LabRadar portion of this review rather than, say, the ammo. Now, while we did not get the 1,312 feet advertised velocity that is on the box, this would be a good example of an instance where barrel length and firearm came into play. With our Beretta 92FS and its 4.9-inch barrel, we had an average velocity of 1,228 feet per second, with an extreme spread of 31, which, if you believe the internet, puts this in the very good category of ammo over 5 shots. If we compare that against the CZ Scorpion, we had an average velocity of 1,422 feet per second, with an extreme spread of 35, which again, if you believe the internet, puts it in the very good category of ammo over 5 shots. With the CZ Scorpion pistol having a 7.75-inch barrel, you can see that we were either quite a bit above or below the 6 inches that the box quoted, and as a result, we either had a velocity that was quite a bit above or below the box quoted velocity. How about we test out a different caliber and type of ammo that also quotes a advertised velocity on the box that could be potentially interesting.
.845, 857, 855, 880, 904, 964,
950, 955, 954,
994.
990.
Now again, this is another ammo where we have a review for it coming in the future. So we're going to keep most of our comments specific to the LabRadar instead of the ammo. For the Smith & Wesson Model 36, we had an average velocity of 868 feet per second with an extreme spread of 59 feet per second. I would say that puts it in the average category of ammo if you believe the internet. Comparing that against the Speed 6, which has a little under a 1-inch longer barrel, 1.875 versus 2.75, we had an average velocity of 963 feet per second, extreme spread of 44, which puts it in the good category of ammo if you believe the internet, over 5 shots. Now again, for both of these firearms, we got a velocity well below the 1,100 feet advertised on the box, and I would say both are easily in the category of a carry 38 special. What gives? Now again, I think this is a case where we are using firearms that don't have a barrel length the same as what they tested this ammo with. They being the manufacturer, and I suspect they probably used a barrel 4, 5, 6 inches long compared to the almost 2 or 3 that we use today. And one of the reasons I suspect that is, well, let's do a little more range footage.
Okay, here we go, Underwood ammo.
Didn't get it. Try lowering your barrel a little. There you go. 1351, 1381. 1367. 1364. 1380.
Now looking at the numbers out of the Rossi Model 92, this Underwood Extreme Penetrator 100 grain ammo, we had an average velocity of 1,373 feet per second, with our extreme spread of 17. If the internet is to be believed, that puts this in the very, very good range of ammo. Personally, I think that indicates that we have got complete powder burn out of this ammo, and they likely charge it with a consistent powder charge and a consistent weight projectile, which probably again means it's very good in that regard, at least from this firearm.
So now that we have covered the limitations that are listed in the manual, that we have seen the Labrador in action, that we've seen the plethora of data that it can provide, knowing this, would we still shell out the insane amount of money one of these costs to buy one for the channel? Absolutely. This LabRadar Doppler radar, it might be Doppler radar 1 compared to Mega Doppler 5000 like your radio news weather has or whatever, but this thing, it's a fantastic piece of technology in my opinion. No, it's probably not going to get velocity at 300, 400, 500 yards or whatever like I was hoping I would be able to do. But if you take a minute and you step back and you think about it, that makes sense. Why? Well, Mega Doppler 5000 is tracking 4 billion raindrops in a cloud or whatever and tell you the direction that that cloud is going. Doppler 1 on my LabRadar is tracking one projectile the size of a bumblebee or whatever, traveling downrange at 3,000 feet per second. There's like 4,000 bees crossing through in between. How do I know? Because where we were shooting at today, we have 16 beehives out there. That's not very many, but that's more than most people are probably going to have around where they're shooting, and we're shooting a projectile smaller than a bee. Well, if this thing can track that small projectile zooming through with all the bees, it's probably pretty frickin' good at what it does. And the numbers that we got were pretty frickin' consistent with numbers that I've seen other people spout out for this same ammo, so I do not have any concerns about its accuracy thus far. In the last couple weeks, since first renting a Labrador thanks to Banner Range and then buying my own, I have now ladder tested 7 different combinations of loads for my 6.5 Creedmoor rifle, of hand loads for long range shooting, and also assessed 2 different factory loads. Between 380, 9mm, and 38 Special, we have chronograph tested more than 20 different brands of ammo the last 2 days, and it's been awesome. And the numbers that we have got have been right on with all the numbers that you see on some of the other channels that review ammo. So again, we have no reason to question the numbers that we are seeing from our LabRadar. Now, for the vast majority of people out there, having a piece of technology such as this are probably unnecessary. You're probably not going to be doing the shooting and different ammo testing and reloading and whatever that might demand having such a sophisticated piece of technology. But there are people out there that are going to reload a ton of different types of ammo or a ton of different loads of one type of ammo and want to fine-tune it to the nth degree, or who want to compare every different type of ammo across every different brand for one caliber or whatever. Anyway, the possibilities are limitless, and really, this is one of those expenses where you don't need it, but when you have it, you really appreciate the advantage that you have. Now when I'm, say, working up a load for my 6.5 Creedmoor rifle, for as far as the LabRadar can track the projectile, I will now be able to tell things like the velocity and how that velocity is either maintained or lost in regard to the weight of the projectile I'm shooting. Now, I often find, because where I live, that it is very windy. It's rare that I get a day without wind, and as you saw in parts of this video, we had like 30-mile-an-hour winds constantly blowing in our face or whatever. Well, that's going to affect the bullets we're shooting as well, and various other things, blowing you around, blowing your fire around, everything else. So when we are doing long-range shooting, I often find that a heavier projectile is more accurate. But that was my from the gut, we're going to say firearm placebo effect. I didn't really know if that was accurate or not. Well, now through ladder testing my 6.5 Creedmoor rifle and my various loads, hand loads that I've created for it, I now have a better idea on the weight of projectile that my rifle likes, how that performs, and then also how the velocity of that projectile is maintained through the course of how that projectile travels. And that can be very useful not only to a target shooter or a precision target shooter, say a competition long range shooter, but also to your hunter. If you are shooting, say, a deer at 100 yards, it's very useful to know how the projectile that you are shooting is going to perform at 100 yards or in or past that, depending on, say, the range that you're going to be engaging your target at. That's very powerful information. Now, you don't need to necessarily go out and buy one of these yourself. As I said, there are places like Banner Range where you can rent this LabRadar. And that's a very useful tool to have at your disposal for a very small fee. When I rented one a couple weeks ago, it was $20. I had use of it for the whole day, though I did have to sign a release and say if I shot it by accident, I'd pay for it, which, you know, that should be without saying. Now, what I would say in conclusion is that I think this LabRadar Doppler Chronograph will be extremely valuable to our channel. Are we going to feature it in every video we do? No, highly unlikely. But we are going to use it in many of the videos that we do, and that's going to be behind the scenes where most people probably aren't going to see it. There's going to be times where most of the time we're going to take, say, a chronograph reading and you're not going to see it, and we might just throw an average at the end, towards the end of, say, a first firearm review, so you get an idea of how that ammo performed through that firearm, things like that. That might not be beneficial to most people, but I suspect there are people out there that want to know, how does most ammo perform out of this firearm? Do I get, you know, good results, bad results, whatever? Because not everything's the same, even if they say it's, you know, looks good. One of the unexpected areas that, well, we're going to definitely test in the future and going forward is the notion that barrel length is the be-all, end-all as far as velocity for the ammo that you are shooting. We got some very unexpected and interesting results the last few days, and we are going to be examining them in detail going forward, which should make this a very fun LabRadar, we're going to call it LabRadar chronograph testing playlist.
Well, I hope you found this video useful. Thanks for watching, and as always, have a good day.